Hello and welcome to the section 11.1 lecture today for Algebra 1 Part 2. We're going to take a look at something that I'm hoping you've seen in the past. I do hope it's a refresher, but it's definitely a good break from some of the stuff that we've been doing. It deals with properties of exponents. And we kind of ran into this in the last section when we were dealing with multiplying polynomials, but we're definitely going to formalize it now and talk about how these rules come to be. So at first here, I'm going to look at what these actually mean. Okay, 2 to the third power means 2 times 2 times 2. 2 to the fifth power means 2 times 2 times 2 times 2, and I feel like a broken record. But anyways, I have 3 2's and 5 2's. Then the question I always try to get students on is there a difference between this multiplication and this one? And the answer is absolutely not. They're the same thing. I made this one made it stand out a little bit more because it was this multiplication symbol. Okay, the other ones were ones that I came up with to mean, to give me my 2 to the third power and 2 to the fifth power. So really when it comes down to it, and I want to simplify this back down, I want to write it as 2 with a new exponent. How many 2's are there? There are 8. And how do I get 8 from 3 and 5? I add them together. So if I have any number to some power times that same number to any other power, that's going to simplify to give me the number to the n plus m power. I add those exponents. In multiplication, we add the exponents. So let's look at a couple of these. For the first one, I have 5 to the third and 5 to the sixth. I'm going to write the intermediate step for a couple of them, and then I'll go to kind of fast tracking it and just doing it the way we know how to do it. So 5 to the 3 plus 6 gives me 5 to the ninth. On this one, I have 3 of them multiplied together, but that doesn't really matter. It's going to turn into x to the 2 plus 3 plus fourth power. 2 plus 3 plus 4 is 9. Okay. On the next one, whenever I have just random numbers in front, I want to go ahead and multiply those together. So I'm going to do 3 times 7, and then I'm going to combine my b's. b to the 2 plus fourth power. 3 times 7 is 21. 2 plus 4 is 6. For the next one, I just want to check. Okay, yeah, we've got some more. For the next one, and for the rest of these, I'm not gonna write that intermediate step. We're just gonna do the work kind of in our head. Numbers wise, I have 2 times 3 times 6. 2 times 3 is 6, and 6 times 6 is 36. 8 to the third, 8 to the fifth, and 8 to the second. That's gonna all combine to give me 8 to the 10th. The next one, 3 times 8. 3 times 8 is 24. X to the 4 plus 2 is 6. Y to the 5 plus 7 is 12. The next one, there's kind of 2 answers that are okay. I'm always okay if you just multiply numbers out. I wouldn't say that in this first one because of what we were trying to do, but 12 and 12, you could either write it as 12 squared or 144. I don't care which way you write that part. But then I have a to the 4 plus 8, which is 12. B to the 12 plus 32, which is 44. On this next one, I can't imagine why I chose to stick with these numbers, because now I'm going to hate myself. I'm going to write out what this means exponent-wise. As a preliminary step, this means 2 times 2 times 2 to the 5th power. Okay, so here we go. There's 1, 2 times 2 times 2, 2 of them, 3 of them, 4 of them, and 5 of them. Ow, I know. It'll be a good thing once we know what the rule actually is. So how many 2's do I have total? 3, 6, 9, 12, 15. 2 to the 15th. And how do I get 15 from 3 and 5? Well, I end up multiplying those exponents. So when I have any number to a power, and that whole quantity raised to a different power, or even the same one, it doesn't matter, I would end up multiplying those exponents. And be very thankful that I don't have to do this every time, because down here it would be, my hand would really hurt. I'll do the same thing on the first couple. I will go ahead and write out the rule. This turns into 4 to the 12 times 5, which is 4 to the 60th. This one is 12 to the 3 times 12, which would be 12 to the 36th. This one would be negative 7 to the 15 times 5, which would be negative 7 to the 75th. Glad I didn't have to write down 75 sevens, or negative sevens. Okay. From here on, I think that we're good if we just say what the multiplication is. 14 times 14 might take you a second, but it's 196. When I have a number involved, and I did hesitate against this yesterday, but that's because there was a plus or minus sign in the middle. I do have to give that 4 to everything in the parentheses. So out of this, I'm going to have negative 10 to the 4th, and then x to the 6 times 4, which is 24. I'll do the same thing here. And so this is a rule, this distributing the exponent is a rule when inside of our parentheses all we have is multiplication. Okay, and if you don't trust it, write it out like I did before, but maybe just kind of scratch work it out before you hate your decision to write everything out. This turns into 1/4. I'm going to put that in parentheses just so I know that the whole thing is being raised to the 3rd power. X is going to be raised to the 2nd times 3rd power, which is going to be to the 6th power, and y is going to be to the 3rd power. So that gets us through the product rule and the power rule. We have one more to talk about, and then some fun problems to wrap it up. I use fun lightly sometimes. On this one, I have 2 to the 5th on top. So there's 5 2's, and on the bottom, I have 3 2's. When I have a multiplication or a division problem where the top and bottom is all multiplication, I do get to cancel things out. And so when I cancel those out, what do I have left? I have 2 to the 2nd power. How do I get 2 out of 5 and 3? And you may be on the right track thinking that we subtract them. A to the n over a to the m turns into a to the n minus m. Okay, so let's kind of go over all the rules that we have so far. I'm going to wait and do that later because I just remembered it is coming up. I'll do the same thing. I'll write it a couple times. This is going to be 11 minus 5, and it's always the numerator number, the numerator exponent minus the denominator exponent. So this is going to turn into 2 to the 6th. This one is going to be negative 4. Numerator exponent minus denominator exponent equals negative 4 to the 4th. For this one, it's about like the problem that I started with. X to the fifth minus the third power is x to the second power. When I have numbers involved, I treat them separately. I say, let's get those out of the way. And it's just going to be that times y to the 11 minus third power. I wasn't going to write it this time, but I did anyways. Oh well. 3 over 12 would simplify to 1 over 4. And this would be y to the 8th power. The next one, I have 49 over 7. That's 7. X to the 7 minus 6, which is 1. And you can decide for yourself whether or not you need to write that 1. Or whether or not you want to. You don't have to, but if you want to remind yourself that that is to the first power, that's okay. And then y to the 12 minus 5 would be y to the 7th power. In the next one, I have 2 over 6. That's the same as 1 over 3. X to the 9 minus 1 power is x to the 8th. Y to the 4 minus 2 power. 4 minus 2 is 2. And finally, 5 minus 4 is 1 for z. Okay. Now, one thing I do want to talk about to kind of wrap all these up is that PEMDAS helps a lot more than just knowing order of operations. If I write it in kind of this weird way, that it's kind of the new way to write it, to mean that I do multiplication and division at the same time, and addition and subtraction at the same time, I see some interesting pairings of letters. When I have an exponent raised to an exponent, so all these phrases are going to start with when I have an exponent. So when I have an exponent raised to an exponent, I multiply those exponents. When I have an exponent multiplied by another exponent, so like the product rule, I add those exponents. And when I have an exponent divided by another exponent, I subtract those exponents. Okay? And so just kind of some other problems that we might run into. When I have a fraction raised to a power, and I kind of glossed over this in one of our earlier problems, that really turns into 2 to the third over 3 to the third. And that's kind of an important idea. Since I have different numbers there, I don't get to do anything else. That's just what I get. So it's almost like still distributing that 3 to the top and bottom. So looking at this one, along with knowing that that 4 has to go to the 2 as well, that 4 gets distributed to 3 different places. Okay? It's going to be 2 to the 4th, x to the 4th, over y to the 2 times 4. And that's what I get out of that one. Okay. So let's go ahead and look at how bad these problems can get. Now, when it comes to problems like this, I encourage you to do something. And the reason I say that is I have a lot of students that look at this and immediately kind of freeze, like, wow, there's no way I could do that. Focus on one thing at a time. Okay? I'm going to focus on the top. I'm going to try to iron out what's going on up there. And the first thing I see is an exponent outside of parentheses. So I'm going to give that exponent to everything inside of its parentheses. And that's all I'm going to do in this first step. So it's a 3 on the outside, so this will be 2 to the third. It might be nice to know what that is. And just so you don't have to grab a calculator, that's 8. And then I have a to the third raised to the third power, so I multiply those exponents. That's a to the ninth. And b to the 4 times 3 is b to the 12th. I also have all that times 4ab to the 5th. And all that divided by 64a to the 5th, b to the 3rd. Let's deal with the numbers first. Let's pull those parts out. So 4 times 8 is 32, and on the bottom it's 64. And I'm still working on the top because I have a's and b's on the top that I kind of need to bring together. I have 9 a's and one more a. I add those exponents to get a to the 10th. I have 12 b's and 5 more. That means b to the 17th. And then on the bottom, just the a to the 5th and b to the 3rd. The fraction, the numbers here, well, that kind of simplifies nicely to 1/2. A-wise, 10 minus 5 is 5. And B-wise, 17 minus 3 is 14. So that problem turned out to be not so bad after all. It looked bad, trust me, I know, it looked bad, but it wasn't too bad. Let's look at this next one. So this 2 out here is going to be very, very busy. But before I get too crazy with that, I'm going to try to simplify everything inside my parentheses first. Because if I don't, my first step would be give the 2 to the 2, give the 2 to the m, give it to the n, give it to the 3, to the 9, and I'm doing that on both the top and bottom. And like I said, that 2 would be very busy. I don't want to do that yet when there's things that I can simplify inside. So let's try to simplify the top first. I'm going to leave those parentheses to have that 2 out there. Looking at the top, I have negative 2 times 3. That's negative 6. M to the 2nd, m to the 9th. That's m to the 11th. N to the 3rd, n to the 1st. That's n to the 4th. All that over 3, m to the 7th, n to the 2nd. And all that raised to the 2nd power. I'm still not going to focus on that. I'm going to try to simplify this even more using my other rules. I could, as I said to start, I could bring that 2 into everything, and that would be just fine. You'd get, if you do it right, you're going to get the same answer. I think this is easier. Negative 6 over negative 3, dealing with the numbers first, is negative 2. M to the 11th, m to the 7th, subtract them and get m to the 4th. I do still need my parentheses. N to the 4th, n to the 2nd, 4 minus 2 is 2. Now that 2 on the outside is way less busy. I have to give it to the 2, to the m, and to the n. So I'll have negative 2 to the 2nd, m to the 4 times 2nd power, n to the 2 times 2 power. That sounds a little better. N to the 4th. And that would be my final answer. And this was a much, much easier second step than having negative 2 to the 2nd, m to the 4th, n to the 6th times, and this is getting ugly, I know, but 3 to the 2nd, m to the 18th, n to the 2nd, over 3 to the 2nd, m to the 14th, n to the 4th. This got really ugly. I didn't really want to do that, but that's what that first step would have been. If I would have given that outside exponent of 2 to everything first. Anyways, go ahead and put down any questions you have over on the left. Otherwise, have a great day, and we will see you in class.